periodic table. It's the greatest cheat sheet ever invented. This is because the elements are arranged by chemical and physical properties. Okay, we were just talking about chemical and physical properties. The periodic table lists the one or two letter symbols of the element together with the whole number, which is the number of protons of that atom. Here's carbon. Okay, so he's got 6 protons. That sits right up top. All right, now the number of protons in the nucleus of the atom increases by 1 as we go across the row. Oh, I kind of erased, I wrote over our friend nitrogen. He has 7 protons, oxygen 8 protons, fluorine 9. Incremental. The table has 3 general areas. See the green? The green means metals. The blue means non-metals, and the area in between, the delineation, are called metalloids. They kind of play it both ways. You don't have to memorize this table. You will always have one handy. You should be familiar with the first 3 rows, and I would like you to learn your way around a bit. So I'm going to ask you to memorize these symbols. Okay? Most of them are pretty straightforward, okay? There are some that take a little bit of work. For example, Na is an element called sodium, and K is an element called potassium. And it's kind of interesting where they come from or not. But just so you don't have to keep looking back at your table whenever you see these symbols used, I need you to be adept to know these letters, these symbols. Meaning they're kind of like the letters of the alphabet for chemistry. Okay. The horizontal rows are called periods. Rows are called periods. The columns, all columns, are called groups. Also, older texts call them families. Isn't that lovely? Why? Because these have similar chemical properties. They belong together just like a family. We're going to find this extremely helpful, okay? Because all we need to know is which column an element belongs to, and we know how he's going to behave in a chemical reaction. That kind of information is absolutely amazing. There is nothing in any other science that is as powerful as the periodic table. Okay. The way we note them is either by Arabic number, the 1 through 18, or you'll also see, where's a good example? You'll see Arabic with a letter. For example, 1A, which you can always see since I've written over it. Okay, and the A's are main group elements. The B's, see these guys are all B's right here. The B's are called the transition groups. Actually, the transition metal groups. Okay. Alrighty. Okay. These below that are held out from the rest of the pack, we're not going to worry too much about those. Those are called the those are called the inner transition elements, the lanthanide and actinide series. We're not going to look at those except for perhaps uranium, and that's just a cursory look when we talk about nuclear reactions. Alright, now here's a nice one because, hey, it's got the names. Right, you can also see that. But what is that number underneath? That is important. This number is the mass of the atom. It is actually the average mass of the atom, or weight, called the atomic weight. Element. Okay, now let's call this atom. Why is it not a integer? It takes into account the natural abundance of the isotopes. So it's kind of a weighted average, or well, let's look at carbon for a second. Carbon is almost 90%. Oh, no, forget it. It is 98.8%. 9%. Oh, golly, sorry. Not 89.9% carbon 12. So this number is almost exactly 12. But if you come over to something like sodium, you'll notice that although 11, if I've got the same number of neutrons as protons, that would be 22. The mass of the sodium must have a heavier isotope weighted into its mass. So these are AMUs, atomic mass units, very, very small numbers, and we're going to find that there is a more useful unit later on. Now, are all the elements found in equal abundance on Earth? Not by a long shot. The most abundant elements on the Earth's crust and in the human body is, ta-da, oxygen. She is everywhere. There are very few metals you will find that are not found as oxides. That means chemically bound with oxygen. And your body is mostly oxygen. Water, by mass, is mostly oxygen also. But notice how few overall elements there are that make up the bulk of the crust and the human body. If we go back to something like, francium here, this means it's radioactive. It's kind of like, it's here, but it's not going to be here forever. There's about 20 grams of this stuff worldwide at any one time. Okay. Now, what is it that makes the periodic table so useful? Well, the elements are arranged in order of increasing atomic number. That is, remember, the number of protons, with elements having similar properties placed in the vertical columns. Remember, those are called the families or the groups. Okay? So if we put them in a line, we can find that helium is an inert gas, neon, and argon. Hey, they all have the same old properties. Why don't we put them together? Lithium, soft reactive metal. Sodium, soft reactive metal. Potassium, hey, it's a soft reactive metal. And this naturally flows into this. Oh, this is a mess. Okay. So here's our friends. Lithium, sodium, and potassium. They all behave the same chemically. They all behave the same physically, to a little bit different regard, but in the general area. And then these guys also behave the same. Anybody who is down a family. Now these families are so important that they are given special names. Many of them are, not all of them. And I do need you to memorize these as well. We have a lot of memorization at the beginning of the course, not so much as we go. But group 1A, called the alkali metals, Alkaline earth metals for 2A. 6As are called the chalcogens. 7A are called the halogens, and 8A are the noble or inert gases. Like I said, there are three broad categories. Metals are located at the top, and they have certain properties like luster. They are ductile, meaning you can draw them into wires. They are malleable. You can beat them into sheets. And on the chemical side, physically they are mostly gray, and they conduct heat and electricity. Nonmetals don't conduct. And they have much different properties from each other.